Hey there, Himanshu this side. Welcome to the lecture number 3 of the chapter sound. So I hope you guys have attended the lecture number 1 and lecture number 2. And in the lecture 1 and 2, what we have done basically, we have understood what is sound, how it is being produced, and we have also got some understanding about the waves, that what is wave. And now we also know that there are two types of wave, transverse and longitudinal waves. And sound wave is a type of longitudinal wave. That's what we know at this stage. And the basic cause behind the production of sound is the vibrations, right? So once we produce the vibrations, then the sound will be produced. So now in this today's lecture, we are going to talk about some application related to it. That what are the properties related to the sound wave. So our major discussion in today's topic will be about the human ear, and then also we'll discuss about the reflection of sound. Then we'll discuss about the characteristics of sound, echo, sonar, radar, and a new concept for you guys, something called the Doppler's effect, which is quite new for you people. Though it's a topic of 11th grade, JEE students has to, and NEET people also have to learn this. But today in our class, we will have a little bit idea about this topic called Doppler's effect. Okay, so now let me begin with the characteristics of sound wave first of all. So what is the characteristics of sound wave? Though already I have explained you in the last lecture as well, that when a sound travels, then there are certain parameters. When this wave is traveling, then there are certain parameters which are related to it. So sound is basically traveling in the form of compression and rarefaction. So this compression, then rarefaction, that's how the sound is being traveling. Now, let's suppose, let us talk about this particle. So this particle is supposed to vibrate this way. It will go this way, then it will come back, again it will go this way, and then it will come back. So that is called one oscillation. In the case of string wave, it was going up down, but in the case of sound wave, it will go left right. I hope you are getting my point. So that is called a compression and rarefaction. So particle vibrates in the direction of wave. Now here let me say, this particle starts from here and goes till this position. So that's the maximum displacement of particle from its position. So this is what we call the amplitude. In the case of wave on a string, we have taken perpendicular as the amplitude, if you remember. Then this was the amplitude. Here this will be the amplitude, maximum displacement from its mean position, right? So this is called the amplitude A. If amplitude is more, we know that the intensity is more, means the loudness. So this loudness term will be decided by the intensity of sound wave. So if the speaker is at a very high volume, means the loudness is more, right? Which means that intensity is more, this amplitude is more. The particles are going up to a far distance now, right? And then they are coming back. Similarly, I have also told you about the pitch. It's just a quick revision we are doing right now. So pitch is basically determined by the frequency, high pitch, low pitch. I gave you the example of Lata Mangeshkar's voice and A.R. Rahman's voice, if you remember it correctly. Then A.R. Rahman's voice is having a low pitch, it's heavy voice, right? At the same time, Lata Mangeshkar voice is very sharp voice, so pitch is very high, means frequency is very high. So the vibrations are taking place more number of times in a second for Lata Mangeshkar's voice, because the pitch is going to be very high for her. So frequency is the property which determines the pitch. And frequency, how do we determine frequency? By the number of oscillations per second, we determine the frequency. So that's what the meaning of pitch and intensity, which we have already discussed in the lecture number 2. Now I'm going ahead with the few more properties, something new for you guys, which is called the reflection of sound. Now, you have a chapter called light, and I am pretty sure that you have already covered this chapter light in the grade 6 and 7 also. So now what we have discussed in the reflection of light waves, every teacher must have started with this, the laws of reflection. So what were those laws of reflection? Reflection means coming back of light, right? So here also it is a wave, and light is also a wave. So actually what will happen when a sound, this is, suppose it's a speaker. Now this speaker is sending the sound wave like this. So just like in the case of a light wave, we were getting the reflection, here also we are getting the reflection. means sound will reflect exactly in the same way. So again, you can see the same thing here also, that just a second. This is the angle of incidence. Hence, this will be the angle of reflection. So I is equal to R. That's how we used to make. If you don't understand this, don't worry. That how I'm writing angle of incidence, how I'm writing angle of reflection. We have to draw a normal here, and then you measure all the angles with the normal. That's what you'll be doing also in the next chapter called light. Okay. There also the similar laws of reflection are used. Here also similarly we have laws of reflection. So suppose if somebody is producing a sound wave here, and if you are the listener, if you are standing here at this place, listener, then you would be able to hear that sound. Though you will be able to hear that sound from two ways. Directly, that is one way, and another way is through the reflection. So there are two ways by which you will be getting the sound wave. So maybe you hear the same thing two times, right? Okay, so that's what we call the reflection of sound. Like the reflecting back means coming back of sound waves. Now let us begin with the echo. It is a property related to the reflection of sound wave only. Very simple thing, but we can understand it in a mathematical way also, right? So what is echo? Echo is basically reflection of a sound wave after a certain time. You must have experienced it. I am not sure whether you have visited a place where there is nothing. It's only mountains there. So if you shout something there, so you will hear your sound again, right? So if I have shouted something, then I'll hear my sound again. Or you must have seen it in the Bollywood movies as well. So when actor is shouting, right? So that time he hears the sound back. So that's what we call the echo. So echo is basically getting the sound again. So echo is a reflection of sound which will come back to the observer, oh sorry, the producer after a certain time gap. Okay. Now there are certain conditions for echo, that when we will be able to hear the echo and something. So there is one condition which I am going to discuss with you now. So first of all, for echo, suppose let's say this is the speaker, or we can say the source speaker, and let's say I have kept one object here. That's a wall, I can say, a very high cliff, you can say. That's a cliff. Now if I produce a sound wave, what will happen? The wave will travel. That's just a representation. Sound wave is basically longitudinal. Okay, that's just a representation. Now it will come back. So that's what we call echo. But the condition is this reflection of sound wave is happening. So let's say at t equal to 0, the sound wave has been produced by the speaker. Now after a gap of 0.1 second, this sound should come back. So actually if this sound is coming after 0.1 second, then I'll be able to hear the echo. If it is coming before 0.1 second gap, let's say I have said something. So let's say I'm speaking the name Sonu. So I will get the sound again, right? But if the sound which I'm getting back, if it is coming within a gap of 0.1 second, once you have released the words, then we'll not be able to hear it, because you will not be able to distinguish whether it is a reflected sound or it is a sound which I have produced, right? So that's what the meaning of echo. That's what the condition for the echo. That suppose if I say hello, so I should hear back hello after a 0.1 second gap. If it is coming before that, I'll not be able to distinguish whether it is a reflected sound or it is a same sound which I had produced. So that is why that's the condition. Now I can prove it mathematically that if this is the time condition, then now how much should be the distance between, because that's how it will be decided. Sound has to travel certain distance and then it will come back. So how much minimum size, minimum distance it should cover. So minimum time it should take is 0.1 second. If time is more than 0.1 second, then I'll be able to distinguish. Yeah, that's the echo, right? I'm getting the sound again. Otherwise, I'll not be able to hear. So let's say that's the source. And here we have the listener. Sorry, here we have some obstacle. So that's the obstacle. Now, what should be this distance between source and the obstacle? Or you can say the cliff. Let us prove it. So let's say this distance is x. I have to determine this distance x, right? Speed of sound wave you can take 340 meters per second approximately in the medium air. So ultimately, what is the total time taken we want? 0.1 second minimum. That should be equal to distance over speed, because time is distance upon speed. Speed is distance upon time. So time is equal to distance over speed. Now how much time it will cover, how much distance it will cover? X while going and x while coming back. So total distance which it should cover is 2x divided by v, the speed of sound wave. So 2x is equal to v. I am taking the cross multiplication, guys. This term I am multiplying with the 0.1 and putting the value of v there. So v is equal to, if you are getting confused, let me write it for you, 340. Now I'm cross multiplying it. So 2x is equal to 340 multiplied 0.1. And from here you will get x is equal to 17 meter approximately. So minimum of 17 meter, in some books you will find 17.2, right? Because they use 344 as a sound speed. So that may vary, but it's not a very big deal. So approximately you can say that the minimum distance should be 17 meter. This x should be minimum 17 meter. And that is why, guys, we do not hear the echo in our day-to-day life, right? Right now I'm taking the lecture for you guys. I am in a studio room, and that studio room is not a very big size, right? It may be a hardly around we can say that around 4 to 5 meters. Yeah, that's it. Okay. Yeah. So this 4 to 5 meter, the sound is going, it is getting reflected from the walls of my studio room. Now they will come back from there, but that sound will come back within 0.1 second. So it may be coming back in 0.001 second. So I'll not be able to distinguish whether it is a reflected sound or it is my sound. All right. But if I am in a room which is of 20-meter wide and 20-meter length, then I'll hear this echo. And sometimes it doesn't happen also. Why? Because if the room is filled with certain things, somewhere you have kept the benches, somewhere you have kept the almiras, in that case the sound wave will be getting reflected from the closer things, right? So it should be an empty room, then only you will hear the echo. And when you go in the mountain area, that's what actually happen. The mountains are very far away from you, and there is no obstacle in between you and the mountain, and that's why you hear the echo, very clear, very beautiful echo, right? Okay, now going ahead, let's do one question. So a man is standing 25 meter away from the wall. This distance is 25 meter away, and receives the reflected sound. Calculate the time after which he receives the reflected sound if the speed of the sound in the air is 350 meters per second. It's very simple now. Time is nothing but total distance covered, which will be uh, d while going and d while coming back. So 2d upon speed is 350. Let me put the numbers here. Divided by 350. Let me just solve it. So 50 by 350, which would give me 1 by 7. So t is equal to how much? If I calculate this, 1 by 7, so 0 point how much? 1 and then 4 meters seconds. So here the time is more than 0.1 second. So I will be able to hear the echo, right? So yes, this echo will be here. Yes, that will be a distinct echo. He will be able to hear it. So that's the idea about the echo, and how this is how the reflection of sound wave occurs actually. Next. Now I hope you understood what is the meaning of echo. Reflection of sound is basically called the echo. Now here let's talk about a very beautiful concept called the Doppler's effect. Let me make it some analogy for you, and then we'll come to the Doppler effect. Okay. So when we talk about a wave, so basically what was a wave? Wave was like this, or if you talk about sound wave, then compression, rarefactions, right? Let's say this wave is traveling in this direction with a certain speed, right? Okay. The person who is standing here, what he is getting? He is getting these wavelets, these waves he is getting, right? Okay. The number of waves he is getting per second is called frequency, because number of waves per second is called the frequency. So number of waves he is getting per second can be determined now if you know the frequency. Now let's see one thing. Let us take one analogy. Suppose here your friend is standing, Sonu, again those old people, and here your friend is standing, Monu. Okay. Now let's say Sonu is throwing the stones continuously towards Monu. He does not stop. Continuously he is throwing the stone towards Monu. And let us say that he is throwing 5 stones per second. Which means that in 1 second he'll throw 5 stones. 5 stones, right? So how many stones Mono will be receiving in 1 second? 5. All right. Mono is standing, he's at rest. He will be receiving 5 stones per second because Sono is standing 5 stones only. But now, what will happen if Mono starts walking towards Sonu? Think about it. What will happen if Mono will start walking towards Sonu? So now will the Mono get, how many stones Mono will be getting in 1 second? More than 5? Less than 5? Equal to 5? What is the difference? Initially Mono was getting 5 stones per second because he was at rest. But now Mono has started walking towards Sonu. Now how many stones he'll be getting per second? So guys, it's very obvious now he'll be getting more number of stones because in 1 second already he was getting 5 stones. Now the upcoming stones which were in the path, in between the path, that also he'll be able to get because he has also started moving towards Sonu. Or vice versa true. If Sonu goes towards him, then also he'll receive more number of stones per second, right? Similarly happens with the wave also. Let's say here we have the source. Source means the person who is producing the sound. And here we have the listener, the person who is listening the sound. What listener is getting? Vibrations per second. So if listener is standing and let's say source is sending, let's say 1000 vibrations per second, right? So if your source is sending 1000 vibrations per second, means 1000 is the frequency, 1000 hertz. So listener is getting 1000 vibrations per second. But what will happen if listener starts walking towards the source? He'll get more number of vibrations per second, more cycles he'll be getting now, right? These cycles which I'm talking about, he'll be getting more now in numbers. Vice versa. If source starts moving towards observer, then also similar thing will happen. The listener will get more number of cycles. So basically what will happen when source goes towards listener or listener goes towards source, in both the conditions he get more number of vibrations per second, and that's what we call the Doppler effect. He get a new frequency now. More number of vibrations per second means new frequency he'll be getting, more than 1000. All right, you all have experienced it. If you have get a chance to visit a railway platform, and let's say you are standing here on the railway platform and the train is coming from the left side. That's a train coming from the left side. Now what will happen? If the train is coming from the left side, then you hear that it's a very high sound. And when the train goes away from you, you will hear that the sound quality has changed. It's a very high sound is coming and then the sound changes. So when it approaches you, means more number of vibrations per second you're getting. So frequency is increasing. When it is going away from you, means less number of vibrations per second you're getting. It means the frequency is decreasing. That's what the Doppler effect is. So one point, when source moves towards the listener, frequency increases. When listener moves towards the source, frequency increases. If source goes away from the listener, frequency decreases. If listener goes away from the source, frequency decreases. So that is what we call the Doppler effect. Got my point? So that's what we define as the Doppler's effect, that change in the frequency of sound when either source or observer moves with respect to each other. I hope I have given you a very simple explanation, right? So just remember that number of cycles per second will be received more, and that's how we said that frequency has changed actually. All right. So that's what is all about the Doppler's effect. And the example you can note down is the railway platforms, train coming. Okay. Now, few more things, simple things, right? Let us have a quick theoretical discussion about them. So one is called sonar and other is called radar. You must have heard them, right? In the news channels maybe, or maybe in some documentaries you have seen them. And I have brought one picture also here. That's the sonar. So actually, what is sonar? What is the full form? That's a very usual common question in your school exams. What is the full form of sonar? So sound, SO stands for sound, N stands for navigation, A stands for and R stands for ranging. Sound, navigation and ranging means with the help of sound waves, we are able to navigate the objects. Means where is the object, right? So which type of sound wave we use here? Ultrasound, high frequency sound. And if you remember, ultrasound were those waves whose frequency was more than 20 kilohertz, 20 to 20 kilohertz human audible range. Less than 20 hertz is infrasonic, more than 20 kilohertz is ultrasound. So for this radar and all, we usually use around 50 kilohertz and more. That high frequency sound we use for the sonar. Okay. Now, how does it work? Very simple. Again, reflection of sound wave. So suppose here you want to detect the objects underwater, right? Let's say the enemy's aircraft is there or something is there, right? So if you want to detect it, then what you will be doing? This is the sonar basically. Here you have fixed the sonar. It will be sending a wave. It will not reflect it in between because there is no obstacle. And now it will hit here. And now after this, what will happen? It will come back. And now just exactly in the similar way, which we have done for echo, we will be able to calculate this time, how much time it has taken, because we have the sensor there, right? It will be calculating the time that, okay, I have sent the signal at t equal to 0 and I have received it back at t equal to 4 seconds. He'll be telling you that in 4 seconds I have come back. So time is equal to distance. The total distance means double, going and coming back. And speed of sound wave, which you can put here in the water. Okay. And from there, you'll be able to find out the value of D. And then this sonar machine will give you the reading that the object is, let's say, 500 meter away from you. So there is a enemy's object at a certain distance from you. So now you should start your task. All right. So it will give you the warning accordingly. So that's what the meaning of sonar, and that's the purpose of sonar. I hope you understood it. It's a very simple thing. So that's how it works. It will be giving you the distance at which the obstacle is. Going ahead with the radar. So what is radar? Radar, see, sound wave uses ultrasound waves, which are of more than 50 kilohertz. But radar uses radio waves. It's again a type of electromagnetic wave, radio wave. Now, radio detection. So RA stands for radio. D stands for detection. A stands for and R stands for ranging. So radio detection and ranging, you should remember the full form. sound navigation and ranging, radio detection and range, and second thing, sorry, radar uses radio waves, sound sonar uses ultrasound waves, high frequency waves. So high energetic waves basically. Frequency high means energy is high. Okay. Now again, it also works on the principle of reflection of sound waves. So that's a typical picture of a radar. Okay. And here also the radar would be sending a signal. All right. And that radar signal would be going from here. Okay. Like this. And there is an obstacle and it will get back the signal. So that's the radar here. Okay. So it will send the signal like this and then it will come back like this. So that's how the simple functioning of radar is. It will go and it will come back. That's how it works. All right. So that's a simple concept, simple idea about the functioning of radar. So I hope you have understood this. What is sonar and what is radar? Sonar means sound navigation and ranging. Radar means radio detection and ranging. Now coming to the last topic of this chapter, which is called the structure of human ear. Okay. And in the structure of human ear, we will have this topic again in the grade 9 also, but in the grade 8 itself I will be giving you the basic idea about it. And yes, of course you will be getting this topic in the biology also, right? So now let us discuss the structure of human ear. Okay. So now there are three parts in which I'll be giving you the analysis here. So first of all, how do we hear basically? Again, when someone speaks, it produces vibrations. So those vibrations will move forward, right? Okay. Now, when these vibrations reaches to our sound, reaches to our ear basically, then what happens after this? So there is a very special device called eardrum. Yes, I'll call it a device only, right? If you take the analogy, then similarly in speakers also, there is something which is receiving the sound. Similarly, in our ears also, there is an eardrum. So that eardrum is basically sending you the, will be receiving the sound signals and that eardrum will vibrate. Okay. Let me give you some terminologies here. Okay. So first of all, sound, ear is basically divided into three parts. One is called outer ear. So I can say that's an outer ear. Then this is called the inner ear. Right. So outer ear and then, this will be called as the middle ear. Yeah. Just a second. Inner ear will be the third part. So this is basically the middle ear, middle part of the ear, you can say simply. Middle ear. And then this is called the outer ear, inner ear. Okay. So outer ear means from where the sound wave is entering to our ear. Sound wave will enter from this place. And what do we call this in the biology terms? We call it pinna. Outer ear is called P-I-N-N-A, pinna. Right. So that's what the outer ear is called, pinna. So sound wave first of all will enter into the outer ear, right? Means basically pinna. And then after this, what is called? So this collected sound which will is collected by the pinna will be passed to the middle ear, right? Okay. And this path is basically, this path is called the auditory canal. Auditory canal. So through pinna it enters, and then from the auditory canal it goes to the very special device, right? Which I just told you, that is called the eardrum. All right. So what is the basic structure? Let us just quickly recall it. Pinna, from where it will enter, and after entering through pinna, what will happen? It will go into the middle ear part, and in the middle ear part, the first thing which it will be encountering is the membrane, the eardrum basically, right? Okay. So at the end of this auditory canal, we have the membrane, right? Or we can call it a eardrum, or there is a very specific name also for this. It is called the tympanic membrane, eardrum, or it can be called the tympanic membrane. Tympanic membrane. So you can call it either eardrum in a simpler language, or you can call it a tympanic membrane. Now this tympanic membrane is the most essential part. This is something which will be vibrating when the sound wave will reach. So what is sound wave? Compression rarefaction. So when sound wave is reaching there, compression rarefactions are reaching there. And now when these compression rarefactions are reaching there, what will happen? We will get the membrane vibrations also. So this membrane is also vibrating like compression and rarefaction. So now when these compression and rarefactions will make the membrane to vibrate, right? After this, these vibrations are amplified also, right? So now inside the ear only, I'm telling you, in the middle part only, these vibrations are being amplified. Okay. And for the amplification of these vibrations, we have three bones. One is called hammer, second is called anvil, and third is called stirrup. So let me just write down. So who does the amplification? This question can be asked in the exam, maybe in the Olympiad exam. So hammer, these are the three bones basically which will do the amplification. Second is called anvil, and third is called the stirrup. Okay, so that's how we do the amplification of the sound which we are getting. Multiple times it is required so that we are able to hear it properly, clearly, right? If it has become low, because it is coming from very far, so it might become low also. Now, this is the part of middle ear. So pinna, it enters, then goes to the middle ear. Middle ear will transfer this amplified sound waves. Basically, these are pressure variations, compression rarefactions. These middle ear will transfer it to the inner ear. Okay, and then this inner ear basically what will do, right? So when this middle ear, middle part of the sound is being transferred, is transferring these sound waves to the inner ear, then it converts them into electromagnetic signals, right? And then it will be processed by the brain, right, with the help of again auditory nerve. All right, so basically middle ear, and with the help of middle ear we convert them into the electromagnetic signal, right? And who converts them into electromagnetic signals? Cochlea, that's the name. So cochlea, which is something which converts into conversion of sound wave to electric signals, because our brain will process only electric signals, and then with the help of auditory nerves they'll be passed through the brain. Okay, and then brain will process, okay, this sound is coming, so you'll get the information. So pinna, you enter the sound wave, then it goes to eardrum, eardrum vibrates, then then there are three bones which is called hammer, anvil, and stirrup. They will amplify the sound wave, and then after we will be transferring this information to the inner ear. That inner ear, before, make sure it will be converting, before it passes to the brain, that it will be converting those sound waves to the electric signals, and once it is converted into electric signals, then our brain will process that information. And how does it go to the brain? With the help of auditory nerves. And who converts them into electric signals? Something called cochlea. I hope you have got the structure of human ear, and that's how we are able to hear, right? Okay, so eardrum is the most crucial. Everything is most crucial, right? So basically what vibrates is the eardrum, and then three bones, hammer, anvil, stirrup, will amplify it, and then conversion so that it goes to the brain is done by cochlea, and then cochlea converts them into sound signals, electrical signals, and then finally we receive the information. Okay guys, then that's all. So now the chapter is over, and I hope you have learned something in these classes, right? You must have got idea about the what is a wave, which is called a disturbance, transverse, longitudinal, two types of waves. Sound is a type of longitudinal waves. I hope you have also got idea about the propagation of sound waves, that medium is required, otherwise there will be nothing to vibrate and we will not receive the information. Then we talked about the frequency, amplification, intensity, pitch, all these terms, the characteristics, and we had a discussion about the reflection, then properties called echo, the phenomena which are happening by the reflection, and then after we have the discussion about the sonar, radar, and finally we discussed about the structure of human ear also. Okay, so that's the complete chapter of sound, and in the grade 9 also you'll be having the same chapter. Yes, I believe you have enough idea about it now. So in grade 9 you will be learning the new things. Okay, so that's all from my side guys. Thank you so much. If you have any doubt, just put it over the PDF. Your doubt will be answered there. Okay then, thank you so much.